students. In this video, we're going to be talking about rules for exponents and radicals. And radicals, if you were not aware, is square root, cube root, all the roots. It's just a generic term for them. So I'm going to open up my foldable, and the first thing I'm going to show you is how to write a radical or square root or cube root with an exponent. So taking the square root of a number is the same thing as taking that number to the 1/2 power, just a different way to write it. And the benefit to doing it this way is that you can simplify using the rules for exponents that I'm going to show you in a minute. So you may have actually learned this in Algebra 1, but I know for some of you it's been a couple of years. So what you're going to do, anything that's inside the radical or the square root will be in parentheses when you write it in exponent form. Everything outside the square root stays just where it is. So in this case, I have a plus 1 inside the square root. So I'm just going to take a plus 1 in parentheses and raise it to the 1/2 power. And that's it. And let's look at the third one. So again, everything that's outside the square root just stays where it is. So go ahead and put the 2. We're taking 2 times, so b plus 4. And it's in the square root, so I want to raise it to the 1/2 power, and then minus 1. Cube root is pretty much the same thing. You just got a little 3 here on the radical to tell you it's cube root and not square root. But pretty similar, cube root means the same thing as a 1/3 exponent. And it's going to work the same way. Anything inside the cube root will stay in the parentheses. Anything outside the cube root just stays where it is. So I want to rewrite the cube root of b minus 5 using an exponent. So b minus 5 in parentheses, and it's a cube root, so I'm going to raise it to the 1/3 power. So the 0 power rule, anything to the 0 power is 1. Kids are really tempted to say 0, but it's not. Anything to the 0 power is 1. So this whole mess, all raised to the 0 power, is 1. Don't overthink it, it's 1. Next one, this whole mess raised to the 0 power is 1. And then 5 plus 1 is 6. So raising powers to powers. So if I have something like this, I already have something raised to an exponent, and then I raise it to another exponent. All you have to do is multiply the exponents. So let's take this one for example. I'm raising everything in parentheses to the 4th power. So I'm raising the 2 to the 4th power, and the x squared, and the y to the 3rd, and the z. Those are all getting raised to the 4th power. So 2 to the 4th, don't really have to do anything different there because the only exponent there is 1. X squared to the 4th, well, I'm going to multiply my exponents. 2 times 4 is 8, so x to the 8th. Y to the 3rd to the 4th power. 3 times 4 is 12, so y to the 12th. And z to the 4th power. And then I'm done with that expression. Second power rule example, I'm raising 5x squared to the 3rd power. And actually this time I'm going to show you why you're doing it this way. So as we know, if we take 5x squared to the 3rd power, we're taking 5x squared times 5x squared times 5x squared. And how many 5s do I have? Well, I'm multiplying 3 5s, so that's 5 to the 3rd. And I'm taking 1, 2, 3, 4, 5, 6 x's, so x to the 6th. So this is basically just a shortcut for doing this every time. And if you're more comfortable doing it the long way, hey, do it the long way. It's not going to hurt anything. Next one is the negative exponent rule. This is the one that kind of gives kids the most trouble because they make kind of a, I don't want to say goofy mistake, but hopefully easily fixable mistake on these. So a negative exponent means to give the reciprocal. So that means if you have your numerator and your denominator, if you have a negative exponent on top, everything that was on top goes to the bottom. Whereas if you have a negative exponent on the bottom, everything goes to the top. So you're basically just switching places, numerator and denominator. So in this example, I've got 5 over x to the negative 3rd power. Now the 5 does not have a negative exponent, so the 5 is just going to stay where it is. But the x to the negative third is a negative exponent. So that means it's in the denominator right now. It's going to go to the numerator, and it's going to lose the negative sign on the exponent, because otherwise we would just have to move it right back to the bottom again, and that doesn't make any sense. So I went ahead and moved it up to the numerator and took the negative off the exponent, and there you go, that's simplified. Next one. So 3x to the fourth, no negative exponents there, just write 3x to the fourth. Oop. Now y to the negative 2, there's a negative exponent. So since it's in the numerator, sort of, right now, that negative exponent tells me it's going to go to the denominator, and the negative exponent is going to just become positive, so y squared. So 3x to the fourth over y squared is what that becomes when you simplify it. I'm going to leave the last one for us to try in class because we actually need to simplify it. After we do this rule, we need to use product rule on it. So save this for class. And let's look at product rule. Excuse me a second. All right, product rule and quotient rule. Product rule means if I'm multiplying two numbers that have the same base, so like 2 to a power times 2 to a power, I keep the base the same and add the exponents. So now if I were multiplying this all out by hand, I would have 2 to the fourth, which means 2 times 2 times 2 times 2, and then times 2 times 2. Well, how many 2's am I multiplying? 1, 2, 3, 4, 5, 6. 2 to the sixth. So the shortcut there is to just take your exponents and add them together. And again, if you like doing it the long way, feel free to do it the long way. But this is the shortcut. This one, so my a's have the same base. They're both a to a power. So I can go ahead and combine them using product rule. So 2 plus 5 is 7, so I have a to the seventh, and then just times b. And the last rule is quotient rule. Quotient means the answer to a division problem. And just like when we multiplied, we added the exponents. When we divide, we're going to subtract the exponents. So on the first one, and again, I'm going to show you the long way, kind of show you why we do it this way, and maybe you'll like the long way better. I have b to the fifth. So 1, 2, 3, 4, 5. B to the fifth right there. And then b to the seventh. 1, 2, 3, 4, 5, 6, 7. Okay. Now I can cancel out b's, which leaves me with just 1 on top, the number 1, because of course I can multiply anything by 1. And b squared in the denominator, which there's your kind of 5 minus 7, which is negative 2. And then, of course, b to the negative 2, using the negative exponent rule, would go to the denominator. So 1 over b squared. Next one. So I have y to the fourth. You know what? Let me rewrite this bigger, because that just looks really tiny to me, and I'm right here in front of it. So I have y to the fourth times 12, and then 3y. So this y has, if it doesn't have an exponent at all, it's a 1 exponent. Just kind of know that, keep that in mind. So I'm going to use my quotient rule and subtract those. And also, by the way, go ahead, don't forget that 12 divided by 3. We know 12 divided by 3 is 4. And then for the y exponent, so y to the fourth divided by y is y to the third, because you take 4 minus 1 and it's your shortcut. So we'll do some examples together in class, and thank you for watching.